In Chapter 10, we are going to be looking at radical functions and geometry. Now, a radical function is anything that includes a radical or a square root. So it's going to be taking the form of y equals the square root of x, and then some things added around it that will change it. But our base function, our parent function as it would be, is y equals the square root of x. So that's our basis, that's our foundation point for this section. So I first want to go ahead and look at what that graph looks like, what that function is going to take the form of, and then look at also its domain and range. So first of all, I'm just going to graph this function. And so since x is being square rooted, I'm just going to look at the numbers that are perfect squares, meaning 1 squared is 1, 2 squared is 4, 3 squared is 9. And so my x terms are going to start there. So some perfect squares would be, first of all, 0. 0 squared would be 0. 1, 4, 9, and let's go 16. If I plug in 0 for x, the square root of 0 is 0. Plugging in 1 for x, square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And the square root of 16 is 4. Next, I'll go ahead and plot these points on my graph. So my first point is going to be at 0, 0. My second point is 1, 1. Then 4, 2. 9, 3. And 16, 4. And you'll notice this is not a linear line, it's not a straight line by any means. There is some kind of curve to it, so I connect these points. Because there is this kind of curve to it. And actually, it's the same curve we saw in the last chapter with quadratics, except instead of being a U shape, this is now flipped on its side and cut in half. And so I continued the parabola on the bottom, you'd see the sideways parabola. So the next thing we're going to look at, this is our parent function, our y equals x square root of x graph. And so let's take a look at the domain and range. As a reminder, the domain is all the possible x values that will work for our function, and the range is all the possible y values. So going back to our graph, here I've just made it a little clearer and a little more neat. Domain. Domain's all my possible x values. Easy way to look at this is what can I not use for x? And remember, x is a square, it has to be square rooted. And so I can't take the square root of negative numbers. So domain is going to be all the x's such that x is going to be greater than or equal to 0. It's all the positive numbers including 0, because the square root of 0 is 0. Now my range in this case is actually the exact same, because if I can only put in positive numbers for my x, I'm only going to get out positive y values. So the range is going to be all y's such that y is greater than or equal to 0. So that's my parent function, my basis, my foundation for this section is that y equals the square root of x, and then my domain being greater than or equal to 0, and the range also being all y's greater than or equal to 0. So let's look at one now that changes slightly. So here, I'm going to graph this new function of y equals the square root of x plus 5. I'm going to state the domain and range, and then compare that to my parent function. And again, my parent function is the square root of x, or y equals the square root of x. Here we go. Again, because I'm square rooting x, I'm going to use my perfect squares for my x's, just so the numbers end up being nicer. So I'll go with the 0, 1, 4, 9, and 16 again. So I plug 0 in for x, I get the square root of 0, which is 0, plus 5, which would be 5. Square root of 1 is 1, plus 5 is 6. Square root of 4 is 2, plus 5 is 7. You should probably be seeing a pattern here. Square root of 9 is 3, 3 plus 5 is 8. And the square root of 16 is 4, plus 5 is 9. Again, I'll go ahead and graph this. Start at 0. Now I have 0, 5 though, so I'm actually going to start up here. 0, 5. Then 1, 6. 4, 7. 9, 8. And 16, 9. Next to my points. So there's my graph. I've found my points, I've plugged them in, I've made my graph. Now let's look at my domain and my range. In this case, again, for x values, I can plug in 0 and everything positive. So my main is going to stay at x, such that x is greater than or equal to 0. My range, however, has changed. This plus 5 at the end here has shifted my graph from the starting at 0, 0 up to starting at 0, 5. So my range now is actually all y's, such that y is now greater than or equal to 5. The reason for this being, the only way to make this graph below 5 for my y values would be to have some kind of negative value for the square root of x, which can't happen. And so we're left with everything greater than or equal to 5. Lastly, we have to compare this to the parent function. Again, that's the y equals the square root of x. And this is going to be moved up 5 or translated up 5.